Hello everyone, my name is Rachel Baker, and today our first guest for the interview will be traveling all the way from the 1880s. This renowned physicist has won a Nobel Prize for his work. So I'd like to introduce you to our first guest. Please tell us your name and about your project.
My name is Albert Mitchelson, and I worked with Edward Morley to investigate the medium that light particles travel through. During the height of my research, it was believed that a medium was required for waves to travel through, such as water waves travel through water, sound waves travel through air, so thus light waves must have a medium to move through as well. This medium was believed to be a light-bearing ether called luminiferous.
Through this project, what were you trying to find in this experiment?
Through this experiment, I was intending to determine the velocity of the Earth through the light-bearing ether by measuring how light changed. To do this, I created a device that sent a single source of light through a half-slivered mirror to split the light into two beams, right angles to each other. This device is known as an interferometer. The mirrors in the device reflected the split light back to the middle to combine in an eyepiece, producing a pattern of constructive and deconstructive interference, thus the name, the interferometer. The hypothesis of this experiment can be summarized as, if the speed of light was constant with respect to the light-bearing ether, through which the Earth was moving, then the motion could be detected by comparing the speed of light in line with the Earth's motion and the speed of light at the right angles to the Earth's motion.
Where did all of your research occur?
The experiment known as the Michelson-Morley experiment took place in 1887 at Western Reserve University in Cleveland, Ohio. My first experiment took place in 1881 at Potsdam. Since the first experiment did not detect any movement, other physicists were anxious to see a repeated experiment, leading me to partner with Edward Morley in 1887 to conduct the more known version of the experiment.
What other significant events were happening in the world during this time?
Many significant events happened during the time I was working on this research. Notable events from 1881 are work began on the Panama Canal, Barnum and Bailey opened the greatest show on earth in New York, the American Red Cross was founded by Clara Barton, and President Garfield was assassinated. Sioux Indian chief Sitting Bull surrendered. Some notable events from 1887, when the more famous work happened, are that work began on the Eiffel Tower and Britain celebrated the Golden Jubilee of Queen Victoria. Other significant world events during the 1880s are the Greenwich Mean Time was used as the standard time to set global time torch, and Henry Seeley patented the first electric clothes iron. Thomas Edison opened the first power station, and the Hayward Square riot occurred in Chicago.
Who else was involved in this project?
My partner on this project was Edward Morley from Newark, New Jersey. Morley was 49 at the time of partnership for the experiment. He graduated from Williams College in 1860. His personal research focused on determining the density and atomic weight of various gases, specifically researching oxygen.
What impact did this research have on the physics community?
My role in the experiment was quite profound. In 1881, I created the instrument interferometer to help research optics in the Earth's movement. My original experiment did not detect any movement. After my lab was burned, Edward Morley offered his lab for the repeat of the experiment. I designed the repeat of the experiment with the help of Morley, and together we were able to announce that while the results were still negative, there was no interference with the light waves and no apparent movement of the Earth relative to the light-bearing ether that was expected to exist. The apparatus that we built floated in a mercury trough, allowing it to rotate slowly. As it rotated, the speed of light of two perpendicular arms would change according to the ether theory, causing a shift in the interference pattern. However, the results showed that no such shift occurred.
This experiment is sometimes referred to as the most famous failed experiment. What did you learn from this failed experiment?
The results of this experiment were not explained until Einstein's theory of special relativity in 1905. It can be viewed that the results of this experiment set the stage for some of Einstein's research, which have made significant impacts on how we view the world and its interaction. The negative results of this experiment did prove that the ether medium expected for light to travel through did not exist as it was originally believed to. While the experiment is seen as the most famous failed experiment, the negative results provided significant information we needed as physicists. Success in the experiment is not solely seen as receiving the expected results, but receiving results that further research and provide new information. While this experiment failed in terms of the expected results, it provided information that the light-bearing ether medium did not exist. Other success on the personal level was shown to me in 1907 when I was awarded the Nobel Prize. So, to receive an award of such high stature, I know that this experiment did have some impact to others outside of my research.
Well, that's all we have today. Thank you, Mr. Mitchelson, for traveling all the way to the future to give us a little information about your famous Michelson-Morley experiment to test what medium wavelight travels through. Thank you, and have a great day.